Hello, Accelerated. This is Miss James, and we are doing a really tough problem. However, this is a necessary problem for you to solve because you're going to need this for the car and the cup. So here we go. A cannonball is fired down a level field at an angle of 30 degrees. If the range is 100 meters, how fast was the cannonball leaving the cannon? Well, first let's set this up. This is a really intimidating problem because it doesn't give you an awful lot of numbers. You know the angle and you know the range, but there are other things you do know. For example, you know the accelerations, and in this case I've made AY negative because I'm making up positive. You also know that the height is 0 because it's down a level playing field. Okay, so typically we start with the horizontal, with the vertical, so let's try that. This is our formula, h equals v0yt plus 1/2 ayt squared, but we have a problem. We have one equation and two unknowns. We don't know v0y and we don't know t. So let's try the horizontal. Maybe that'll do us better. Oh, yeah. Here again, we have one equation and two unknowns because we don't know v0x or t. Okay, let's try them both together. Uh-oh. We still have two equations now, but we have three unknowns. We don't know v0x, we don't know v0y, and we don't know t. Bummer. Okay, here's what we can do. We can replace v0x with v0 cos and v0y with v0 sine, and here's what we get. Now let's look at it. Well, we have only two things we don't know. We don't know v0 and we don't know t. So that is a solvable situation. Hooray! We have two equations and two unknowns. At this point, I've also taken out ax because we know that's 0, so the d equation looks a little bit better. All right, so here we go. We've got to solve for t in the bottom equation and then plug it into the top equation. So when we solve the horizontal equation for t, we get t equals d over v cosine theta. Now let's plug everywhere we see t in the top equation, let's plug in that value. So here's our equation from before, h equals v0 sine theta t plus 1/2 ayt squared. Every place we got a t, we put in d over v0 cos theta. This looks really disgusting, but I promise, hang with me, it will get better. Okay, so let's let the algebra begin. We can cancel the v0s from the first term and then combine, and we can square all the things in the square for the second term and then simplify a little bit. So that's what we get in the bottom equation. Now let's plug in 0 for h and solve. We can move one of the terms to the other side of the equation, and then when we do that, one of the d's will cancel in each term as if we divided by d on both sides, and we can cancel a cosine theta on each side as if we multiplied by cosine theta on each side. And when we solve that or simplify it, we get sine theta equals minus ayd over 2v0 squared cos theta. We're now down on the third line. And now we cross multiply. So once we cross multiply, we can then solve for v0 squared. And that's what we get in the last term. v0 squared equals minus ayd over 2 cos theta sine theta. So remember how disgusting it looked. This doesn't look fantastic, but it looks okay. Now it's time to plug in the numbers and solve. We can plug in for d 100 and for theta 30, and we get the answer ultimately of 34 meters per second. Guys, when you first see this, it looks terrible. I promise as you do it more and more, it'll feel better. This is your first foray. Bye.